Hello everyone, today we are going to solve this standard deviation question on GMAT statistics. This is a very simple question involving a fundamental concept. Still about 70% of the people get it wrong. If you want, you can pause here to solve the question yourself and then go for the solution. Please keep a pen and paper ready so that you can follow along. First, let's talk about what you will gain from this video. You will understand what is the impact on the standard deviation of a series when you add a new number, especially a new number that is equivalent to the mean of the series. Second, you will look at a particular trap that GMAT can ask and you can fall into and make a mistake. And finally, you will look at some of the mistakes people make and the wrong answers people connect, mostly because they either fall for the trap or they don't know how to solve questions like these. What you must know to solve this question is, first, what happens to the mean of the series when you add a new number which is equal to the mean of the series. And if you need to review that concept, the link is above and also in the description. And finally, you should know the standard deviation formula, especially the xi minus m calculations, which is the spread of each data point from the mean. Once you're equipped with these things, we can quickly solve the problem. Let's look at the solution. So the first concept you must know is that when a new number is added to the series and the new number is equal to the mean, then the mean of the series does not change. And the second concept is that standard deviation is equal to the root of sum of each term minus the mean whole square divided by n. So let's get started with the solution. So let's get started with statement 2. In statement 2, we are given that this x equal to 2. There is nothing else given about the question, so clearly this is insufficient. We need more information. In statement 1, we are given that the sum of these three numbers x, y, z is 15, which means the mean of the old series, which is the mean of x, y, z, is going to be 5. And now let's apply the xi minus m formula, and I've already given this into the tables. So xi minus m, which is the distance of each of the terms from the mean, would be x minus 5, y minus 5, and z minus 5. In the new series, where we are adding a 5, the xi minus m's would look like x minus 5, y minus 5, z minus 5, and 0. So I'm going to write old here and new here, and let's see the standard deviation, what it would look like. So for the old series, it will look like x minus 5 whole square plus, so I've written the standard deviation of the old series and the new series. A couple of pointers here. We have determined that the mean for the old one and the new one will be 5, because for the old one in statement 1, it's given that the sum is 15, so the mean will be 5. Since the new quantity we are adding is equal to the mean, from concept number 1, we know that the mean will not change. So the mean will remain 5. As you can see, the numerator is kind of the same, but denominator here is 3 while the denominator here is 4. So you will tend to mark the answer as new is less than the old, and hence statement number 1 is sufficient to answer the question, and you would mark the answer as A, which will be incorrect. And there is a trap here. A is the most chosen answer choice for this question, and that is because there is a trap here. And if you fall for that trap, you would mark the answer as A. The other popular answer choice for this question is E, and that is usually because people are lacking the fundamental knowledge about standard deviation and the two concepts that I have laid down here. So why is A wrong? A is wrong because the greater than or the inequality here only holds if x, y, and z are three different numbers other than 5. If these all three numbers are 5, their mean will still be 5. However, the numerator would be 0 in both the cases, which means there would be a equality. So statement 1 will yield yes sometimes when it is greater and a no sometimes when it is equal. Hence, statement 1 is insufficient to answer the question. The correct answer to this question is C, because when you combine statements 1 and 2, then you know that at least one unit, which is x equal to 2, is different from 5, which means the numerator of these formulas cannot be 0, which means the only possible case would be the inequality where old is greater than new. The equality possibility is not possible anymore. Hence, the answer to this question is C. When you combine both the statements, you have sufficient information to answer the question. Let's quickly review. We talked about how if we add additional point which is equal to the mean of the mean of the series does not change. We talked about when you add additional data point which is equal to the mean of the series, the new standard deviation can be less than or equal to the old standard deviation when you add a number equivalent to the mean of the series. The equality holds only when all the numbers are the same and the standard deviation is the 0. In every other case, the inequality will hold. However, you need to know that the numbers are unequal to give a yes or no to the asked question. And that was the trap in this question. I hope you found this helpful. If there are any questions or doubts, anything else you want to talk about, please leave a comment. Thank you. All the best with your preparation.